Hello, 7th graders. Today we're going to look at solving systems of equations by graphing. So we have a few steps when we are graphing systems of equations. First, we need to graph each of the equations. We can use any method. So that means we could use slope-intercept form and graph our y-intercept and move according to our slope. Or we could graph from standard form and use that cover-up method where we plug in 0 for x and solve for y, or plug in 0 for y and solve for x, and then graph your y-intercepts. Next, we want to find and label the point of intersection. So find that ordered pair where the lines meet, and this is the only solution, or if there's a unique solution, which we'll talk about later, that satisfies both equations. Finally, we'll just check the solution with the original equation from the linear system, just like what we have done previously. So for the first example, my equation is already in standard form. So I'm just going to find my intercepts from that. So let's first find that x-intercept of y minus x equals 3. That means I'm going to cover up y, or plug in 0 for y. It goes away. So all I have to do is divide by -1 on both sides, and I get x equals -3. Next, we're doing the same thing, except for this time finding our y-intercept. So we'll plug in 0 for x, or cover up x, and we're just left with y equals 3. So nothing new there. We have now our x-intercept and our y-intercept, and we can graph those. So our x-intercept, you can see, is right here at -3, and our y-intercept is up here at 3, and you can see they drew the line and added our arrows to it, and also labeled the line. Now we just need to do the same thing with the opposite line. If I use the cover-up method and solve for y first, let's just say, I just am left with that y equals -1. Well, you can see that they graphed a point there already. Next thing, doing the exact same thing, using that same equation, except for this time, instead of covering up that x, we're going to cover up our y, and we're with x equals -1. We can also see a point there, and they drew their lines, and they extended it, and also labeled the line. So finally, the last step is to actually find the solution. That's where the two graphs meet. We can see where they intersect, and that's at the ordered pair of -2, 1. That is our solution. And now, just like what we did previously, we're going to check our work. So we have our first equation, the y minus x equals 3. We can plug in our 1, which is our y value, in for y, minus our x value, which is that -2, and we get equals 3. Well, we can see that 1 plus a +2 does equal 3 indeed, so that is true. So far, so good. Now we have to do the same thing with the second equation. We have that x plus y equals -1. We can plug in -2 for x, 1 for y, and -2 plus 1 is -1, which does equal -1. So once again, we're good to go. That actually is our solution. Go ahead and pause the video, try this second example on your own, come back and see how you did. So I went ahead and I rewrote that first equation, 2x plus y equals 7 right over here, and I decided to turn it into slope-intercept form this time. I subtracted out the 2x on both sides, I'm left with y, and I get -2x plus 7. So right off the bat, I can graph my y-intercept, which is 7 right there. From there, I'm going to move according to my slope, which is -2, or -2 over 1. So that means I'm going to go down 2 to the right 1, down 2 to the right 1. And I can draw my line, draw my arrows, and label that line. I turned my second one into slope-intercept form as well. So I had y minus 3x equals -3. I added 3x to both sides, and I'm left with y equals 3x minus 3. So the graph that I have here is a little bit goofy because it doesn't give me room to actually graph my y-intercept, which would be -3. So instead, I'm going to go ahead and find my x-intercept and then graph that, and from there move according to my slope. So I just went ahead and rewrote that line. I'm going to use the cover-up method and cover up my y, divide by -3 to find my x, and I get x equals 1. So there I went and plotted and from there moved according to my slope, which is 3 or 3 over 1. So going up 3 to the right 1, and there is that point of intersection. We can already see it. So you draw your line, add your arrows, label your line, and find that point. I went ahead and rewrote that ordered pair. Don't forget that your ordered pair needs parentheses and needs to be separated with a comma. So our solution here is 2, 3. And of course, we can go and check our work. So I started with y minus 3x equals negative 3. I plugged in my x and my y into that equation and got 3 minus 3 times 2 equals negative 3. Well, negative 3 times 2 gives me that negative 6. So I have 3 minus 6, which is negative 3. And that does equal that negative 3 on the right side. So far, so good. Now for that second equation, 2x plus y equals 7. Well, I plugged in 2 for x, 3 for y. 2 times 2 gives me 4. 4 plus 3 gives me 7. And 7 does equal 7. So we know we did it correctly. And that is all. Come to class with questions, and I will see you then.